Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you understand how to test for symmetry. So I kind of outlined some rules for symmetry here. I'm going to go over them real quick and then we're going to take a look at three examples. So imagine I've got some sort of equation, and if I can take that equation and replace x with minus x, if I get the same equation back again, what that means is the plus or minus sign on x doesn't matter. And that means that the equation has to be symmetric about the y-axis. If I can take an equation, replace y with minus y, get the same equation back again, then that equation, the graph of which must be symmetric about the x-axis. If I can take an equation, replace x and y with minus x minus y, if I end up with the same equation, I've got something that's symmetric about the origin. So I'm going to go ahead and demonstrate these tests here and how to apply them. And let's take this one right here. So first test, if I replace x with negative x, this equation would read y equals minus x squared minus 2. Now by the time I square this, we just get x squared minus 2 because a negative sign squared is positive. I've got the same equation back again, so this equation must be symmetric about the y-axis. Notice if I replace y with minus y, I've got minus y equals x squared minus 2. And if I move this over to the right, this now reads y equals minus x squared plus 2. Not the same equation, no symmetry involved with that. Furthermore, if I replace minus x, or x with minus x and y with minus y, I don't have any symmetry. It will not be the same equation. So this is symmetric about the y-axis. Let's take a look at this one. If I replace x with minus x, that's going to be minus x cubed minus y squared equals 5. And this minus x cubed, by the time I take that minus sign and cube it, we're going to have minus x cubed minus y squared, equals 5. And if you'll pardon me for a moment. Okay, sorry about that. Back to what I'm doing here. So let's see. Where were we? Oh, so in this example, we replace negative x, or x with negative x. This equation is not the same with this, so there's no symmetry for that. If we replace y with minus y, this is going to read x cubed minus y squared equals 5. Now, by the time we take negative y and square it, we're just going to end up with y squared, because negative 1 times negative 1 is positive. And you'll notice this is the same as this equation here. So this is indicating symmetry about the x-axis. If we replace both x and y with minus x and minus y, that's going to change the sign on this term and not this term. And what we're going to have is not the same equation, no symmetry associated with that. I'm going to skip writing that out. All right, last example over here. If we, I don't know that I copied it down quite right. Oh, this was supposed to be equals. Y to the 5th equals x to the 4th plus 2. Replacing x with minus x, we're going to have y to the 5th equals minus x to the 4th plus 2. Notice by the time we take that minus sign and square it, this ends up being positive x to the 4th. This is the same as this equation. Therefore, we have symmetry about the y-axis. And again, it's because we can change the sign on x, get the same thing back again. That gives you y symmetry. Now, if we change the sign on y, and I write this out, this is going to read as minus y to the 5th equals x to the 4th plus 2. By the time we raise this to the 5th power, this is going to read minus y to the 5th equals x to the 4th plus 2. And you'll notice this is not the same thing as what we had. And again, that's supposed to be equals. So there's no symmetry involved with this. And if we change both x and y, this is going to read minus y to the 5th equals minus x to the 4th plus 2. And by the time we apply the powers here, this minus sign is going to end up negative. That's going to end up with negative y to the 5th equals, this will become positive x to the 4th plus 2. This is not the same as the original equation, so no symmetry involved with that. So these are just meant to be examples of how to test for symmetry. You test for symmetry about the y-axis by changing the sign on x and seeing what it does to the equation. If you get the same equation back again like we did here, you definitely have symmetry about the y-axis. You test for symmetry about the x-axis by changing the sign on a y. That was done here. See how we take this equation and replace y with minus y, but by the time you square that sign, it becomes this, which is directly the same as this, demonstrating x-axis symmetry. And I guess I didn't go through an example of one that was symmetric about the origin, but I can make one up quick. You know, if you had, say, x squared plus y to the fourth equals 2. If you change the sign on both the x and the y, and by the time you take that even power, you get the same equation back again. That one, here's an example of something symmetric about the origin. By the way, I'll leave this as an exercise to the reader, but if you test this for both x and y-axis symmetry, you're going to get all of it. So anyway, video is just intended on being kind of introductory video on how to apply these tests. I hope that this has helped. Have a great day.